Hello guys, welcome to my YouTube channel. In this video, we will talk about another machine learning algorithm called as logistic regression. Okay, so this particular algorithm is used when we have a data set which we want to classify into two different classes. So the classic example would be we have to classify whether a patient is having the cancer or not. Okay, so if he is having a cancer, we treat it as a positive class. If he is not having the cancer, we treat it as negative class. Okay, so if we just plot the data, if that is with respect to classification, it looks something like this here. So I have just plotted some hypothetical data here, y against x, and you see the red dots here, these are our actual classes. So you see these things, you can treat it as belonging to negative class, okay, and these things here belonging to positive class. Okay, just assume this for this respective data set and this case. Okay, now with respect to linear regression, we have our hypothesis defined as theta transpose x, correct? And this theta transpose x in turn takes the form of theta 0 x0 plus theta 1 x1, right? This is more general way. This is a simple univariate linear regression. So if we apply the same hypothesis to this particular data set, this will give us a line somewhere like this, right? So this particular kind of straight line we will get using this particular linear hypothesis. So this is theta transpose x, which is our linear regression. Okay, but this linear regression is basically used to predict the continuous values. Okay, but those continuous values will not make any sense when we have to classify the given data set like this, positive or negative class. Usually we want to have the output from the hypothesis between 0 and 1. Okay, so we want the y to take the values between 0 and 1. Okay, so how we can convert this linear regression hypothesis to give us the output between 0 and 1? How we can do that? So if you visualize the output between 0 and 1, we want the curve to be something like this. Okay, so if I just draw the curve, it should look something like this. Okay, so this is how we want the curve to be, hypothesis to be. We want like this. So why we want like this, I will tell you in a while. So now that we got to a point where we understood why the continuous values are not desired with respect to classification problem, we will see how we can convert this particular hypothesis to give us the value between 0 and 1. So we have to basically shrink this hypothesis to give us the value between 0 and 1. Okay, so how we can do that? All we have to do is we have to apply a function to this particular theta transpose x here called as sigmoid function. We have to apply sigmoid to theta transpose x. So how this will look like? So in a general way, we can write it as 1 by 1 plus e power minus theta transpose x. Okay, so this will be our new hypothesis. So what we have done here, we have taken the linear regression hypothesis theta transpose x and we just shrunk those values or the output provided by that linear function to have the values between 0 and 1, so that this will give us the probability that y is equal to 1 such that given x and parameterized by theta. Okay, so what this imply? So if this gives us the value greater than 0.5, okay, we treat the given data set belonging to class 1, okay, or positive class. Okay, if the probability is less than 0.5, then we treat the given data set belonging to class 0 or negative class. Okay, if it is greater than or equal to 0.5, we classify the given data set as positive data set. If the probability is less than 0.5, we classify the given data set into negative class. So this is how we do it. And this particular output from this hypothesis is it it's the probability that y is equal to, I have already written here, right? Y equal to 1 given x parameterized by theta. So this is the output of our logistic regression or sigmoid function. So how do we read it? So mathematically this is read as, I'll just write it here, it will be a single line. Probability that y belongs to 1 or positive class given x. Okay, what are our x? These are our features, correct? Right? So given x and parameterized by theta. So thetas are our learnable parameters, correct? Parameterized by theta. So this is how we will read this mathematical notation. Probability that a given data set belongs to positive class given x parameterized by theta. So this is in turn is a conditional probability. Conditional probability. Okay. So what's the condition given here? So we have already given x and the parameters theta. So using this, we will apply our hypothesis e power minus theta transpose x, and the output will be the probability that this particular x belongs to the class y equal to 1. Okay. So that's what our logistic regression function looks like. Hope this is clear. If you guys have any questions, post it in comment section. This is just the first part of logistic regression. In the next part, I will talk about the cost function that we are going to use for logistic regression in order to arrive at the global minimum. Okay. So till we see in the next video, happy learning guys. Bye bye.